So in yesterday's class, we had discussed the calendaring and die casting. Now I'll move on to the next type of casting, that is rotational casting. In case of rotational casting, it is generally used to produce hollow particles such as balls, tall, rainbows, or whatever the syntax that we are going to see. For manufacturing those type of fiber materials, generally they are going to use this rotational casting. Here, the compounded thermoplastic material is in the form of a fine powder, which is poured or it is taken in a hollow mold, and that hollow mold is rotated. The apparatus which is going to be used there, so it is going to be rotated with mold simultaneously along with the primary and secondary axis. So this is the sketch. So here this is the primary axis and the secondary axis. So continuously in both the axes it is going to rotate it. So the whatever the fine powder is there, that will be filled on the casting and it will be continuously rotated with respect to the moving operation. Once it gets moved, the reason why it is going to be molded is once the mold is being closed, the whatever the mold which is outside, it will be heated out. So that heating operation is heated simultaneously. While heating, the overall rotation is going to be rotated with respect to both the axes, as it says primary and secondary axis. With the help of this rotation, the whatever the fiber powder that we are going to use, it will be get melted out. It will be get melted out. So that melting will distributed uniformly with the plastic formation and the entire surface and the inside cavity within inside surface of the inside cavity of the mold. And one more thing, a pressurized fluid is going to be injected inside that because it has to get the particular shape. The hollow shape has to be obtained. To obtain that hollow shape, a pressurized liquid is going to be fed to that and it will be continuously rotating. So after continuous rotation with respect to a particular amount of time, a chilled or a cold water is going to be used or it is sent to cool down the surface. And automatically by cool downing it, it solidifies the shape of the surface. Whatever the surface shape is there, the mold or the fiber which is going to be used, it is going to be solidified with respect to the shape of the surface. Afterwards, once the molding has been done, at the next moment, they are going to use or they are going to open the product and it is going to be removed from the settings. Whatever the setting that we are going to consider, it will be removed. Once and while the material is going to be utilized, here the one more thing what it has to be taken care is it has to be cured afterwards. A small amount of additional finishing has to be made. A sudden cooling has to be made. Those are all has to be done. So that is what the curing operation. And when the mold opens, here most of the materials that are manufactured is of thermostatic plastic type because it is a pre-polymer and a curative mixture and also curative mixture, and also it can be fed into the mold in a liquid form. And curing can be done under rotation at any elevated temperature. So that's the reason why they are going to use a thermostatic plastic instead of thermoplastic, especially in case of rotational casting. Here, for a large extent, especially the PVC articles like rainbows, hollow balls, and are generally manufactured with respect to the help of this rotational casting. Here, PVC curing can be done with physical relationship between PVC and liquid plasticizers. So that means whenever the physical curing, PVC curing has to be done with the help of your PVC and liquid plasticizers, it can be easily done. The gelation process where it takes place at a temperature around 500 to 200 degrees centigrade. A fine powder of PVC is used, and automatically the formation, the liquid plasticized is going to be formed, and uniformly with stabilizers and coloring agents to whatever the substance. Especially, we are going to get a paste-like substance which is having low viscosity, and this paste substance is generally we are going to is going to be fed. So this plastisol is going to be fed to the inlet wall. So here I think you're able to see this is the inlet wall and this is the outlet wall. First it is fed to the inlet wall. Whatever the rotation is going to be done, the remaining whatever is remaining which after the usage of the plastisol, it will be taken out from the outlet. It will be taken out from the outlet, and finally the hardening operation is going to be done. Here the product in future is heated with respect to the temperature, and the final fusion whatever is required is of having a particle plastic the resin particles which we are going to term it as plasticizers. Generally the final product whatever we are going to get is going to be taken out, and a water spray is going to be sprayed on it, and especially that water spray whatever we are going to provide, it is for generally for curing purpose, because the hardening has to be done as in case of your thermostatic plastic. Once the temperature is gets varied, the hardening operation is going to be considered. So that's why regarding the conditions, we are supposed to decide how much amount of working is going to be taken care. Next, especially in case of this rotational casting, so here whatever the components wherein the hollow component has to be made, and at the upper end the outer body has to be strong enough for sustaining certain polymers or fibers. Generally, they are going to do with the help of this rotation casting. Like as I said, the examples initially I told you for hollow articles, rain boards, whatever we are going to see, the fiber boards and your overhead tanks, and as well as the certain storage tanks. If you're going to see the water filter tanks, those are all will be manufactured with the help of this rotation casting. The next is film casting. Especially this film casting is generally used or taken out with respect to the polymer sheet. Here in this, with the help of this film casting, we are going to produce the polymeric film. So this polymeric film is a solution which in an appropriate concentration of polymer with a suitable solvent is allowed, and a particulated end is going to be placed on it, and whatever the material is going to be mixed with the polymer which is going to be mixed with the suitable solvent is forced on a roller, so that roller will resist. So like I think you are able to see here, I just taken the example in the sketch. So the resin inlet is going to be fed. The extruder is going to send the sheet with the help of the die. The whatever the material is there, it will be get rolled, and this casting drum is going to form it in forms of a thin sheets or film. So then the machine is going to draw it, and finally once it come back to the tender, so it will get expanded. So that expansion is going to be calculated with respect to the polymer melt film. Whatever the requirement is there, so with respect to that requirement, it is going to be transfers, and that transfers is going to be pulled out sorry, the transverse is going to be pulled out and it is going to be rolled out on a wind roller. So this wind roller is of a chill roller. This once the filament or the polymer film is going to be manufactured, the temperature has to be get reduced. To reduce the temperature, generally what they are going to do is they are going to use a cold roller. So that cold roller will reduces the temperature of the film and it can be easily wounded on a circular rounding object. So like your polymeric films are generally we are going to see in printing of printing ribbons. So it's a polymeric film. Your photo film, whatever we are going to see, it's a type of a polymeric film. It's not a purely polymeric; it's a type of polymeric film. So, like the different applications that we are going to see they are going to consider it. So the next is most of the available varieties that we are going to see are, as I said, the photographic film, the cellophane films. Those are all is going to be considered. Especially here, the rollers, whatever we are going to see. So that rollers is a fixed with a metallic belt, which in turn rotates it. And also the solvent, whatever the evaporation. Once the filament is being manufactured or the film is manufactured, the roller has to be cooled down. So that coolant, as I already told you, and at each stages, the solvent, whatever is there, that has to be get evaporated. So that's why the cold roller and as well as the heater is going to evaporate the solvent, and finally we are going to obtain the film, whatever the polymeric film that we require. Or generally, it will be regarding the applications. If it is for a photographic film, then certain amount of chemical and it has to be stored in a closed and then dark environment. For another type of certain cellophane sheets, like the polymeric sheets, which are used for adhesive purpose, the film sheets, then that will be manufactured regarding the applications. Like that, this film casting plays an important role wherein the working operation is going to be taken. So this is the differences. The first one which we have discussed in the today's class is rotational casting and the second one is film casting. Now I'll move on to the next, compression molding. Here, especially this compression molding, the main working principle of this compression molding is with respect to the working operation. When a char is placed on a cavity, a punch is going to be pressed on it. Once the punch is going to be pressed, then automatically with respect to the velocity and force, the force of the upper mold is going to be pressed on it, and finally a molded part is going to be used. So this type of molding process is generally we are going to consider it as well compression molding. Here, this type of molding process are used to produce articles like thermostatic plastics. Here a figure shows. I think you're able to see the shared screen. So in that they will be having two halves. The one is upper half and the other one is lower half. It usually consists of a cavity, and upper half has a projection which fits inside the cavity when the mold is closed. So the gap between the upper half and the cavity will give the shape of the article or the particle that is required. Especially in compression molding, the thermosetting material is subjected to heat and pressure in a single stroke. Here, the molding is accomplished by a particular temperature and pressure, which is having a minimum of around 200 degrees centigrade and having a pressure of around 70 kg per centimeter, respectively. Regarding the applications, this is a minimum molding temperature and pressure. If regarding a higher amount is, then we can design. Here, the actual temperature and pressure, which will be depend upon the thermal and other properties of the material, as I said. Here, regarding the actual temperature and pressure, so this is a minimum required. And regarding certain materials, you require more number of higher amount of temperature and also higher amount of pressure has to be undergone. So that's why regarding the materials, whatever we are going to use, especially in case of compression molding, so the temperature and pressure is going to be utilized. Here, the compounded material is placed in the cavity, as you can see. So here, within the cavity, the compounded material is placed with full fill. That is, they are going to fill it full overall with respect to this part, and they are going to fill it. And as the mold closes to the drawn. So that is whenever the mold is going to close to this particular region under pressure, the material is squeezed. So whatever the material which is here, it is going to be get squeezed out between the two halves, and whatever the cavity present, this is the cavity which is present inside it. So with respect to the cavity, sorry, and whatever the shape or the cavity which is there, it gets aligned to that. And whatever the excess material is present in that, it will be flows out in form of a thin film. And this thin film is known as the flash. And under the influence of it, it gets cured and hardened with respect to the shape. Whatever the shape is there, with respect to that, it will get cured and it will be get hardened. And finally, whatever the material which is present or the mold which is present, it will be released with the help of the pin. So this is the pin part. So the knockout pin, it will push us out, and finally the mold house is going to be removed, and the cavity will push us the molded part. So this is how the working operation of the overall compression molding is going to be considered. Here, especially for certain types of material, generally they are going to come across this type of compression molding process. In case of compression molding, as I said, the three main parts is with respect to your knock pin, lower mold off, and upper mold off. So the lock pin, the knockout pin is going to be used at the end to remove the molded part. And these two parts are generally utilized. The force which is going to be applied, it will be from the upper mold itself, not with the lower mold is a fixed one. The upper mold is going to be used for application of the force. Higher amount of force and pressure is going to be fed on it. So the next is injection molding. Here, nowadays, most of your plastic materials or the fiber materials or PVC materials that we are going to use, it is going to be manufactured with the help of this injection molding only. Because the manufacturing cost, the unit is huge, but the manufacturing process, whatever we are going to see, it is of a less time process. Here, we are going to manufacture, sorry, thermoplastic materials. We are not going to manufacture thermosetting materials. Here we are going to use only the thermoplastic material. Here, the cost of the equipment is relatively high. If the production rate is more, then they can afford this, especially the injection molding. Because the setup, whatever you are going to see in the sketch, the whole setup is having a high cost because the mold, whatever the mold that has to be used, it is also having a particular amount of value and a particular amount of shape. So that mold has to be manufactured with the help of a fine particles wherein we can use certain amount of materials. A good quantity of molten thermoplastic is going to be manufactured. Molten thermoplastic has to be used, and a good quality of product has to be manufactured. In the same time, it has to be cold, it has to be solidified with respect to the shape of the mold in a fraction of minutes. It has the product has to get manufactured. So like that, all the operations has to be carried forward within a fraction of time. So that's why the cost is more as compared to you as compared to any other products that we are supposed to use. Wait a minute. Then regarding the sketch, it consists of a feeding compound. This is the feeder, the hopper feeder. So these are the rotating screws which moves polymer into the mold. So these two are the heaters. So till this point, it will be in the powder form. Once it sends, so these are the heater pointers. So they are once inside the hopper, it will be in the granular form. It's in case especially the like seed form, it will be there. So it will be fed to that roller, and that roller, once it starts rotating, the screw type roller, it starts rotating, it will melt the polymer and it will inject with respect to the dye. So here there will be having two different parts, the upper and the lower part. Here the lower part is going to be moved regarding the operations. Here, the materials are generally in form of granules, pellets, powder, and that will be whatever the coloring that is also is going to be used. Here, the pressure is applied through hydraulically driven piston. Here, the pressure, whatever you are going to see here, so the compression of the dye, it will be applied through hydraulic piston. Also, it is going to be pushed with respect to the mold fitted and at the end of cylinder. While moving with respect to the hard zone of the cylinder, a device which is going to be used to help to spread the material uniformly inside the hot cylinder. So that generally we are going to term it as torpedo. So this torpedo is used. So that is what the movement, whatever you are going to see, the rotation. So that will be used for spreading the material, which in turn ensures a uniform heat distribution. The molten plastic material in the cylinder is injected with a small nozzle. So I think you're able to see this is a small nozzle. With the help of this nozzle, it is going to be injected. While injecting, high pressure is going to be built on it. Here the mold which is used, it is of a simplest form, which in turn having two parts. One is a movable and the other one is stationary. So here the right hand side is the stationary and the left hand side is the movable part. And the stationary part is fixed at the end of the cylinder. So I think you're able to see this is the cylinder, the outlet of the cylinder, and it is the stationary part is going to be fixed to it. By using mechanical locking devices, the mold is held in the position and a pressure of around 1500 kg per centimeter square is injected. So just I had taken an example, is going to inject it, and the locking device has to be skillfully designed because it has to pressurize still a particular amount of time. So that's why locking device has to be correctly designed. Further, a proper flow of molten material, whatever the molten material is going to be flowed, has to be flowed within the interior regions of the mold, and it is achieved with the help of preheating the mold to an appropriate temperature. Generally, this temperature is slightly lower than the softening temperature because if the temperature goes to the softening temperature, then you are not able to remove the material. Again, the mold is going to get softer. So, to obtain a correct material and automatically the process has to be considered. Generally, what they are going to do is they are going to use a temperature which is lower than the softening temperature. Once the mold is filled and it is cooled, the material is going to be taken out and the whole operation is going to be repeated several times, either in manually or automated mode to get the number of parts. Where generally this type of injection molding, wherein the mass production has to be made. Generally, for producing mass products, they are going to use this type of injection molding techniques. So this is a type of molding technique as compared to your compression molding. Here for each cycle, especially for each cycle, in case of compression molding, we have to add a charge. A person or a user or the worker has to add the charge. But in case of your injection molding, the working operations, whatever we are going to make, or the material which is going to be fed, so it can be fed continuously through the hopper. If the material comes to an end part, the hopper can be filled and it can be used. So that hopper and the water channel, whatever you are going to see, it will be used with respect to the temperature gradient. If the heater provides maximum temperature, so it should affect the properties of the material. Then automatically that has to be cooled, and the overall system has to be controlled in a particular environment. That's why regarding the applications, they are going to decide what temperature has to be taken out and what pressure has to be considered. So all has to be taken considered. So now we'll go with respect to the next type of molding, that is blow molding. So this blow molding are generally used for manufacturing your PET bottles. That consists that is used for certain containers, whatever the PET bottles that we are going to see in our houses, soft drinks, your certain types of water tank that we are going to see, thermoply. Generally, these are this type of molding are generally used for thermoplastic materials are used. Different materials like polyethylene, polycarbonate, polyvinyl chloride, polystyrene, nylon, acrylic, acrylonitrile, and polypropylene, which are used for the molding processes. Here, it consists of four different stages. At stage one, paration is ready. Paration means it is used for the material flow, and then the next stage, the mold, which closes the paration at the end point. So this is the point where so this is the material. So these two are the molds. So this is the material. The yellow color, whatever you are going to see, is the material, and this is the end point wherein it closes the end pointer. And once the material gets hardened, so here it is going to be pressed. The two parts, whatever you are going to see, the left hand and the right hand side is going to be pressed down. And while pressing, a compressed air is also going to be blown on it. So that air blow is with respect to the shape, whatever the shape that we require, and also the thickness. Everything is going to be decided with respect to the extruded die itself. The thickness and of the material, whatever is to be used, the all will be decided initially. And once the material is going to be fed into it, a compressed air is going to be injected on it. So that compressed air is going to be used or set with help of this blow-fill. And once it is going to be energized or the pressurized air is going to be provided, there will be an expansion until a particular amount of contact has to be obtained with respect to the interior of the hollow mold. So that cold operation is going to be provided and it will be utilized. So that operation code amount is going to get cooled out and a rigid thermoplastic article is going to be formed. Once the mold is open, so there will be having certain excess material. So that excess materials are with respect to this point. The bottle excess material, the lower level is going to be trimmed off, and the upper level, the finishing of the bottle has to be trimmed off. These two trim operation has to be made. That is what the final processing operation, post-processing operation of the polymer manufacturing. Once these two operations has been made, the extrusion process or the technique, whatever we are going to obtain or the parts that we are going to get, is going to be termed as generally we are going to term it as injection or extrusion blow molding. Especially this type of blow molding, as I said, having nowadays in most of the applications, they are going to use this type of blow molding process. So this blow molding process, whatever you are going to see, it can be fixed. It can be fixed, especially at this end point. The continuous material will be fed. So here they are going to provide this blow molding and it can be easily used. So these are the different types of molding that we are supposed to consider while manufacturing any of the polymer components. Still more module topics are there. So I'll come up with respect to the coming classes. Generally, in this blow molding techniques, and as well as your injection molding, your film casting, compression molding. In rotational casting, in yesterday's class, we have discussed calendering, die casting. So these are the different molding and casting processing techniques with respect to the polymers. From the last around 50 years, there were different processes of converting any of the polymer materials into finished products. Nowadays, we are using different processing and different machining operations. And these machining operations are going to be utilized regarding the material. So the whatever the material that we are going to use, what type of material has to be considered, which type of quality has to be used, what type of granules, what type of pallets, what type of powder form, what type of heat, what amount of pressure, what at what temperature the heat has to be. So what type of heaters has to be used, a continuous heater or a particular form of heater. And also, I think nowadays you have observed, especially in case of fiber, you are going to see the color formation. So that color formation is going to be added with the help of certain additives. The chemical compositions is going to be added. So with respect to the chemical compositions, you are going to get red, blue, different colors is going to be mixed. Whatever the color you require, they are going to inject it. In standard condition, it will be of a black color. And regarding the color, what we require, black or white colors. Regarding the colors, what we require, they are going to add it. Especially in case of black color, whatever you are going to see, it will be most of the time it will be having a recycled plastic, the black color, because there we don't require any color formation. So once the material is going to be melted out, so there will be having a color, standard black color is going to be used, and that will be used for the injection molding process. So that is what, especially in case of your material considerations. And in case of your injection molding as well as your blow molding, we can use both your thermostatic and thermoplastic or thermostatic. Regarding the applications we are going to manufacture, the one thing is, in case of thermostatic, we are going to use a liquid type material. But in case of thermoplastic, we are going to use the granules, the filling material, and also the material is going to be hardened in case of the thermostatic. In case of thermoplastic, the material is going to be cooled out within the device itself, and whatever the temperature is required to remove it from the die, it will be fed regarding the application. So this is how the overall application or the manufacturing process of your polymer is going to be considered. So